In this video, we'll be looking at two harder questions in method of substitution and integration. Let's start from example 15 here. The question itself is very complicated because it includes x cubed, square root of x to the power 4 plus 1, as well as they are all in the denominators. It's very hard. But yet, the question hints us to use the substitution of u is 1 over x. So that's why we follow straight the instruction first. We first let u to be 1 over x, but I prefer to write x to the power minus 1 because you need to differentiate, and having a number in the index will be easier for differentiation. So as a result, du will be take down the power, which is minus 1, power reduced by 1, which is power minus 2, and you have this afterward. As a result, the question now turns from 1 over x cubed, square root of x to the power 4 plus 1 dx, it now turns to 1 over. So for u is 1 x to the power minus 1, that means u is 1 over x, according to the instruction, or in other words, x will be 1 over u. So as a result, our x cubed turns to 1 over u cubed here. Similarly, x to the power 4 turns to 1 over u to the power 4 plus 1. Next, for du is minus x to the power minus 2 dx, you have to work it out very carefully what is dx actually. Minus sign move to left hand side. X to the power minus 2 turn to the left becomes x squared du. So I will put shortly here, minus sign here, and then multiply to x squared du afterward. Of course, we don't keep the x in the expression because now we turn the integration in terms of u. So as a result, we need some more steps to simplify it, where 1 over u cubed square root of 1 over u to the power 4 plus 1 multiply to x squared. We use the same way, it turns to 1 over x squared, not x squared, it should be u squared, and then du. Now, you can use the way will be numerator multiply together, which is a 1, denominator multiply to denominator, so that's why it turns up to be, let's wait, is minus integration 1 over multiplying u squared, that means 1 over u, square root of 1 over u to the power 4 plus 1, and du. It's still very complicated, right? But now we go and take a look on how we can simplify the denominator. Now we look at the denominator, 1 over u to the power 4 plus 1. You can combine it to turn to u to the power 4 plus 1 divided by u to the power 4. If you take square root on it, that means it now turns to 1 over u squared, square root of u to the power 4 plus 1. And now I will put the expression back to my answer. So the denominator becomes now 1 over u, multiplied to 1 over u squared, square root of u to the power 4 plus 1 du. Afterward, you multiply u cubed up and down. So now it turns to u cubed over square root of u to the power 4 plus 1 du. Oh no, can you see that the expression is still very complicated? Comparing this one to this one, so there's not much benefit about it because it seems like the cube, x cubed, originally at the bottom, now turns to in the denominator. And once the u cube is on top, now we have an easier way to continue to the question. The next job is, can you see that when you differentiate u to the power 4 plus 1, it gives you 4u to the power 3. So that's exactly the expression on top. So as a result, now we can use a very simple substitution by letting, for example, v equal to u to the power 4 plus 1. And in this case, dv will be equal to 4u to the power 3 du. And that you will see that the u cube on top in the denominator is u sub. So now we work out the answer. The expression now becomes u cubed, I keep it short c for a short while. The denominator becomes a very simple expression, just square root of v, while du will turn to 1 over 4 u cubed dv afterward. The most important thing about the choice of the substitution is, can you see that the u cubed will be totally cancelled to each other? And as a result, we can simply integrate minus 1 over 4 1 over square root of v dv. And this one, it seems to be hard, but yet if you write it like a polynomial, that is v to the power minus 1 over 2, then the question is solvable. It can be integrated quite easily. So as a result, you still go ahead for the way how you integrate x to the power n. So it should be minus 1 over 2 plus 1. V would be 1 over 2, and you add c for the constant. Next, we have minus 1 over 2, v to the power 1 over 2 as the answer. And do remember that v shouldn't be in the answer, but we should have x, because now it's a question of x. And then so v you resume to u, which is u to the power 4 plus 1 and power 1 over 2. And finally, you need to go back to the substitution. U is 1 over x to the power 4 plus 1, 1 over 2 plus c. The answer looks a little bit weird, so it may be one choice of answer, or you may continue to simplify it as like 1 minus 1 over 2, x to, if you put the fractions together, should be 1 plus x to the power 4, x to the power 4, 1 over 2 plus c. So you bear in mind that x to the power 1 over 2 means square root of x. So as a result, the denominator can be further simplified, so which gives you minus 1 plus x to the power 4, 1 over 2 here, whereas the bottom will be 2x squared plus c. But somehow I would think it's an optional, so you may just end at the blue one, so to be the answer. Next, we have another question about method of substitution once again. But for this question number 16, so there is a prior part talking about an identity. So in order to simplify the left hand side, so we write left hand side equal to u cubed plus 1 over u plus 1. So it's a test whether you still remember the identity about u cubed plus 1, which is u plus 1, u squared plus 1, and then so the middle part should be minus u, so for the answer. So at last, the red part will be cancel each other, so giving you u squared minus u plus 1, which is the right hand side. So if you totally forget about it, so this is an identity talking about a cubed plus b cubed equal to a plus b, and then a squared minus ab plus b squared. Oh, you forget it, right? So that's why in this question, I'm going to introduce you another little trick in showing an identity, which is, can you see that the most easiest part of this one will be, how about we just think of multiplying the expression in green together and see whether it's u cubed plus 1. So you're actually proving the same identity. So as a result, another way I'm going to show you will be, so instead of recalling the identity of u cubed plus 1, but we will be consider u plus 1 multiplied to u squared minus u plus 1. It's just simple expansion. And you will see that it's u cubed minus u squared plus u squared minus u plus 1, and that's why you have u cubed plus 1. As a result, you turn u plus 1 to the left-hand side by using division. So that's why u cubed plus 1 over u plus 1. It will be equal to u squared minus u plus 1 finally. You'll find that the green one will be definitely easier because number 1, it just uses expansion. Number 2, you need not to remember the identity a cubed plus b cubed in the answer. Next, let's start looking at part B. It's definitely a very hard question because it consists of power 1 over 2, power 1 over 3, as well as even the guided substitution, the hint is about a very weird power, 1 over 6. But yet we will still go ahead. We start the question by letting u to be x to the power 1 over 6. So that's why du will be 1 over 6, the power down, power reduced by 1, minus 5 over 6, and dx. And you observe that the question will be finding dx, so that's why I change the order, so it turns to 6, x to the power 5 over 6, du equal to dx. For your convenience of the job afterward. But now I see another problem. The problem now will be I'm integrating x to the power 1 over 2 and x to the power 1 over 3 in the denominator. But my substitution is 1 over 6. So that's why we need some rough work beforehand. Can you see that x to the power 1 over 2 will be x to the power 1 over 6 and power 3? So as a result, in the question, the denominator first term will change to u cubed. Similarly, x to the power 1 over 3 will be x to the power 1 over 6 and then squared. So that's why the second term in the denominator will be u squared. Together with the dx and du, you have 6x to the power 5 over 6 du. And now I have to turn this one into, can you see that it's u to the power 5? If yes, the question can be finished very soon. The 6 I move it to the front, and now in the denominator is u to the power 5. Bottom you will u cube and u square. And after cancellation, you can cancel u square up and down. And lastly, you have divided by u square, you have u cube on top. You change another color, u cube, and at the bottom you have u plus 1 du finally. Next, the question is a little bit weird because the power on top, u cube, is still a little bit complicated or may not be fit with u plus 1 as another substitution. But yet, compared to the original one, x to the power 1 over 2 and x to the power 1 over 3, so it's somehow much simpler. Next, I go and see how we can use part A, because there should be some reason we need to prove part A, right? So that's why I read my expression on top again. So it's about u cube. It raised my concern, should I write as u cube plus 1 and minus 1 so as to make the expression u cube plus 1 in the question? And the answer later on you will see that yes, it's definitely useful. Because now after you write plus 1, minus 1 in the expression, your expression becomes there are two parts. The first one will be u cube plus 1 over u plus 1, which is identical to part A. Whereas the other part will be minus 1 over u plus 1, which is about log. Do you understand it? If no, let's listen and continue to listen. Next, I will split them down. So you have u cube plus 1 over u plus 1 for the first expression, while the other one will be minus 6 of 1 over u plus 1 du. So if you remember, for about 1 over, it's about 1 over x dx will be equal to log absolute of x plus c. So what if you have x plus 1 or u plus 1? The same. So it's log 1 over log absolute x plus 1 plus c. So if you forget the idea, please go back to the notes and revise it. Whereas for the first one, because the expression u cube plus 1 over u plus 1 is defined already, it is as simple as a polynomial u squared minus u plus 1. Each of them can be integrated one by one separately, and then so that's why the question now becomes solvable. Okay, the next one will be log and absolute u plus 1. I will add the integration constant at the end. So at last it will be, okay, so the first one will be 1 over 3 u cube minus 1 over 2 u squared and plus u, and minus log and u plus 1. The integration is finished, so that's why I start writing the constant c at the end. And then now to simplify the expression, you have a 2. Be careful that u cube you have to turn back to the original one. So that means it's power 1 over 6 together with the cube, so it's 1 over 2. Next one is minus 3. U squared, that means it's x to the power 1 over 3. 6u, so it will be 6x to the power 1 over 6. And last one, absolute u plus 1, it will be x to the power 1 over 6 plus 1. So it finishes the question. So that's all for this video. So in conclusion, you will see that both questions are very hard, so that's why the question gives you a guiding substitution to start it. Don't be afraid of it and try it out. So at last, you will see that by different measures, the expression will be simplified so that you can integrate it by your some old method. For example, the first one will be just substitution, while the second one will be using part A, the identity, to help you to simplify the expression. So hope the video helps you a lot. Goodbye.